Welcome to episode 3 of Viewing Unity Through the Looking Glass. In the previous episode, we made a pachinko board out of built-in components and game objects. It was, of course, a metaphor for life and death. However, in this episode, we will be addressing the fact that it's really hard to see anything by exploring a couple of ways that we can get the camera closer and allow it to follow the ball as it falls. But before we can get to that, let's address a mistake caused from the cavalier creation of my pachinko board in the previous episode. In the hierarchy, you'll see an awful lot of pegs. Now, this is a totally fine hierarchy in terms of functionality. However, in terms of maintainability, it's an intimidating hot mess. Something that you hope to never hear from your peers. So, let's clean this up. We'll start by making a couple of empty game objects. I'm going to name mine based on the letters seen in my board. We also want to make certain that these objects are more centralized with the things that they'll eventually contain. So move them to be positioned somewhere near the center of the letters or the groups that you made in your board. Typically, you would do this the other way around, where you would make the container first, but this is what I like to call a teachable misdirect. Now we'll move all of the pegs inside of the game object containers that we made. Oh, that's so much better. Your future self will thank you. So, besides cleaning everything up, what did we do? Well, let's imagine that we're making a model of the solar system. We would probably start out with a giant styrofoam ball to represent our sun. And we know that each of the planets orbit the sun, so what we would do is take various colored balls, stab them through, and attach them to our sun, thus completing the model. Now, whenever we move our sun, the planets move with it. When we rotate our sun, our planets orbit around it. The planets essentially have become dependent on their sun for their positioning. Similarly, the PEGS transform no longer defines its position and orientation based on its data alone. Instead, its transform defines how it is positioned and oriented relative to its parent. Changing the values in its transform will move it away or closer to the parent's position. And if I select the parent instead and move it to the left or right, when I return to the peg inside of it, its position data has remained the same. And this is because its relative position, or its local position, hasn't actually changed. It's still the same distance away from its parent. However, its global or world position has. Which finally brings us back to the original problem of the episode. How can we get the camera to follow the pachinko ball? Well, the simplest way is to just make it a child of the pachinko ball. So let's do that. Well, this is exactly what we wanted. It just would make everyone sick and is completely wrong. What you're seeing is that the camera is rigidly attached to the pachinko ball, its position and rotation tied exclusively to the ball's position and rotation. So, as the ball rotates, so does the camera, the effect being that the ball always looks upright on the screen, which is disconcerting because we know the ball is supposed to be falling. Unfortunately, this just isn't going to work. So what do we do now? What component or Unity system do we attach to this to get things the way that we want to? Well, we've kind of exhausted our options. The Unity well of nice things has dried up. So it's time for us to venture out on our own, using our own intelligence and imagination to create a component that does exactly what we need it to do. Right-click down on the project view and select New Behavior. I'm going to name it something sensible like Rigid Camera Follower, but you're free to name it whatever you want, like Ninja Progress Tracker. But that would be silly and unnecessary. Double-click on it to open it up. It'll open up a script editor for us to make changes. If we look at our script, there are a couple of things going on here, but we're not going to be concerned with them just yet. Follow along with me for now. First, we're going to add a new transform. This transform is going to act as a reference to the transform component on our pachinko ball. We can use this in code to get things like the position and rotation, which we'll use down here in the update method. We want the camera to move its position so that it lines up with the position of the ball. To accomplish that, we want to take the transform of the camera and set its position equal to the position of the ball's transform. Now, this still isn't quite right because this will have the effect of making the camera be in the exact same position as the ball. The camera might be a little too close to draw the ball, which will ruin everything. Instead, we want to define an offset from the ball to position the camera with. Let's add a vector3 offset, then add it to the way that we calculate the camera's position. Now let's return to the editor. Your code changes will take a moment to recompile, but once they've finished, you can start placing your custom components on objects within your scene. Let's add the follower component to the camera. You can do so by either dragging it out from the project view to the camera's inspector, or by hitting the Add Component button and searching for it. You'll notice the two fields that we defined are listed, the target and the offset. The target is a drag and drop that is expecting a transform component to be dropped into it. You can drag any object in the scene that has that component. Let's drag the ball into that slot. Next, we'll need to define our offset. We're going to define it as slightly below and away from the ball. Now let's move the camera out of the ball and hit play. And there you go. Another step done on the way to mastering Unity. In addition to building scenes, you can now make components to solve the special problems that come up when you're making your special game. In the next video, I'm going to deep dive into all those things I told you to ignore in the script earlier, because they actually are very important. In the meantime, take some time to explore what other things you can do with a script. Look up what's on a transform in a rigid body. See if you can make something cool out of what you've learned so far. There's a link to the project in its form at the end of this video in the description if you want to catch up. And if you have any questions, leave them in the comments. And if you still like this intimidating hot nonsense, please like and subscribe for more videos. I'm a person, and thanks for watching.